Okay, so this first function, doing the first difference, I notice that I do have a common first difference, so this one is linear. Okay, so that common first difference is the rate of change or the slope. Okay, then to get the y-intercept, I kind of have to go backwards. So something plus 3 equaled 5, it must have been 2. Okay, so we weren't asked to graph it, but just to help me visualize, y-intercept is 2, then... Okay, so domain, linear, I can have all real numbers. Range, I can go down forever, I can go up forever. Okay, so as I go forever to the right, the graph goes up forever. As I go forever to the left, the graph goes down forever. Okay, over here I notice to get from one term to the next, I have to multiply by a common ratio. So this one must be exponential. Okay, so the b value, the common ratio, is a half. And then a is the 0th term. So again, going backwards, something times a half equaled 16. It must have been 32. Okay, so this graph would look something like this. Okay, so domain, I can use all real numbers. But range, I never quite get to 0, but I can go up forever. Okay, so this one's a little different. As I go forever to the right, the graph approaches 0. And as I go forever to the left, the graph goes up forever. Okay, last one. Okay, not linear, there's no common first difference. Okay, but there is a common second difference. So this one is quadratic. Okay, equation, I see the a value is half of 6, so 3. The c value, the 0th term, I need to work for. Okay, so the change in the first difference, something plus 6 is 7, so plus 1. Okay, so back to the actual values. What plus 1 is negative 1? That'd be negative 2. Okay, so the c value is negative 2. Okay, so I've got 3x squared plus bx minus 2. Okay, so let's plug in f of 1. So when x is 1, y should be negative 1. Okay, so we got 3 plus b minus 2 equals negative 1. So b plus 1 equals negative 1. So b equals negative 2. Okay, so 3x squared minus 2x minus 2. Okay, so let's plug in some points to make sure. So when I plug in 1, 3 minus 2 is 1, minus 2 is negative 1. Plug in 2. Okay, so 4, 12 minus 4 is 8, minus 2 is 6. Try 3. 3 squared is 9, times 3 is 27. Minus 2 times 3 is 6. 27 minus 6 is 21. Minus 2 is 19. Okay, domain. So I know for a quadratic I can input all real numbers. Okay, so unfortunately here, the range, I need to know what the vertex is. So again, I'll do negative b over 2a, the axis of symmetry formula. Okay, so negative b becomes negative negative 2. 2a becomes 2 times 3. So 2 over 6, which reduces to 1/3. Okay, so axis of symmetry is 1/3. And then we need to calculate the y value at that point. 1/3 minus 2/3 plus 6/3. That'd be 5/3. Okay, so I actually made a mistake. I forgot it's -2, not +2. Okay, so then -1/3 minus 6/3 is now -7/3. Okay, so the vertex is at 1/3, 7/3, and because a is positive, I know this parabola opens upwards. Okay, so this will be the lowest y value. Okay, and then for my graph, I can see the end behavior. As x approaches infinity, f of x goes up forever. And as x approaches -infinity, x again goes up forever.